This is a conversation with Tobias Holmes. Tobias is a quality assurance manager at Blue River Technology, which uses computer vision and robotics in agriculture. Blue River was acquired in 2017 by John Deere. We begin this interview with an introduction to agriculture and the problem that Blue River is working to solve. This includes talking about row and non-row crops and herbicide resistance, both of which I knew very little about before this conversation. After establishing the problem, we talk about how Blue River systems work, quality assurance and testing and hardware, machine learning and weed spraying, the acquisition of Blue River by John Deere, the future of robotics in agriculture, and on education. This is the Sense Think Act podcast. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Tobias Holmes. Would you introduce yourself, Tobias?
I'm Tobias Holmes. I am currently the manager of quality at Blue River Technology here in Sunnyvale, California. Subsidiary of John Deere Corporation, and yeah, I've been working in robotics for about 6-7 years now.
Would you tell me a bit about Blue River?
So Blue River, the company started out with our co-founders, Jorge Herod and Lee Redding, a couple of guys from Stanford, decided that they wanted to bring high technology into the agriculture space. So years ago, probably about 10 years ago, they started out doing carrot harvesting and
Did you say carrot harvesting?
Carrot weeding. Sorry, carrot weeding, and so basically, weeding? yeah. So basically, being able to look at carrots and be able to clean out the weeds that are around the carrot, so that the carrot actually gives you more. You reap more of the harvest. You get more of a yield from the harvest, and that was something that was interesting. There was a problem that was happening in the world. They were tackling that. Using various robotics technologies, and talked to a grower who was like, "Hey, you guys have a nice technology here, but where I really needed to be utilized is in weeding of row crops." And so Blue River transitioned from carrots.
What are row crops? So I don't know that much about agriculture, and I don't know about how carrots maybe are not row crops. What's a row crop?
So row crops are you typically think about a farm, and when you're on a farm where a grower grows, they grow their crops into these very uniform rows and across their entire field, and that just allows them to get the maximum amount of yield from a particular crop you're trying to grow. Then it maximizes the space that you have in order to get the most yield out of it.
So you just plant them like optimally spaced in lines. And why are carrots not row crops? Like I would just assume everything is planted in a row.
So carrots typically are they're kind of scattered around, and you just kind of like throw the seeds as you go out and plant them. Whereas
so they're everywhere.
Row crops you actually you use machines that are very, particular about where they grow, where they are. There's less ambiguity in the where they are placed. They're very, very structured and very, very every 10 inches, just depending on a particular crop. They're they're 10 inches of space from each other, 30 inches, from the next row. It's very, very prescribed, whereas non-row crops are, they kind of are planted in a row, if you will, but what typically happens is you plant a couple in a row, and whichever one is the best vibrant one after a little bit of time, you kill the other ones, and then you keep the one that you want. And so
Gotcha.
Blue River did that kind of work in agriculture in California. You can imagine there's lots of vegetables, fruits that are grown here, and they're grown in that manner, where you plant a couple of them as you go down, and the ones that's the most viable, that's the one you keep and you kill the rest.
Okay, and you kill the rest so that the one that looks most viable or best at that time has more resources available to it, less to compete with in that space,
That's
and
right.
thus a better harvest, maybe?
That's
Like you
right.
get a
And
few
so
better quality ones.
that's right. You want to give every person wants the bigger, juicier strawberry, bigger, juicier carrot,
Yep.
whatever that is. And
Huh.
so that allows you to say, okay, hey, I planted these in a nice bed of a fertilized ground, and whichever ground is whichever one out of the three or four that is more viable, that's the one that I keep, and then I kill the rest. That's right, so that you give
Hmm.
you get more yield. Is what we
So,
typically call it. A grower typically is concerned about the yield of the crop that they are planting,
mhm.
and they want the most yield for the
Yeah.
amount of planting that they've done.
So they have a certain amount of space and they basically want to get as much product, carrots or whatever it might be, as possible for that
That's
given
right.
amount of land.
That's absolutely right.
Okay. And so with row row plants, row crops, and non-row crops like carrots, does the machinery change for? Because I'm imagining like a big tractor driving down tracks, and so I'm thinking for the non-row crops, which you said are kind of in rows anyways. Does it is it like squishing a bunch of them? Um,
It,
because the row ones,
it,
I would imagine it's going kind of in the seams between the rows of plants.
and so yeah, so you can imagine it. There's like these little mounds of dirt
Yep.
that you create, and even depending on where you are in the country, on the world, that can be different. But
Oh,
essentially, you're maximizing the land space, and you're maximizing the ability of that particular seed to give you the best yield. And
I
so the
think I
transition,
understand.
and so the transition is you don't carve out so much land because you don't know when particular crops like that are fruits and vegetables. You don't
Hmm.
know which one will be the one that actually takes hold and it is the champion, if you will, of
Yep.
that part of the land. So you put three or four of them down to see which one is really taking the resources out of the ground.
Yep.
In a row crop, you know that, hey, if I plant this seed here, it's probably going to grow. If I plant it in perfect places, soybean, and the particular row crops that we're talking about, soybean, cotton, corn, if you plant them there, they're probably going to be just fine.
Yep.
The,
Uh,
the, the thing that'll be the resource, so the resource wouldn't be the resource like pull, wouldn't be weeds, it would be no, excuse me, so I said that wrong. In a vegetable crop, you want to plant multiples because you don't know if the crop itself will take. In
yeah.
a row crop, you know the crop itself will take, but then there's competition as weeds,
Yep.
and so now you have to kill the weeds. In vegetables and in fruits, you need to plant multiples because that seed may just not grow right on its
Mm.
own. So you can't just plant one and I know that one's going to grow. You got to plant multiples because out of the if I plant at least four, one or two of those guys are going to grow, and
Yep.
then you take the best out of the group. Whereas
Yep.
in row crops, I plant a seed. That seed's going to grow. The only competition is weeds,
Yep. I
and
see.
and so in that situation, you're planting seeds that are going to grow. You just now need to make sure that you provided the best environment
Hmm.
in order for it to grow.
Gotcha. So if I understand correctly, when you have the non-row crops, you just have like a hump of soil that goes back in a row, effectively,
Yes,
even though it's a non-row crop, and you just like throw seeds all over it,
that's
and the
right.
plants will come up anywhere in that big wide row,
That's
and you
right.
kill the ones that look
Are
less
not
promising to
viable.
save the
That's
ones
right.
that are more promising.
That's right.
Okay. And in the row ones, you just have a narrow row where
You
it's
have
seed,
a
seed, 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 seed,
seed
and they
seed
all
after
take.
seed. That's right.
And so in the non-row ones, you are killing the competing ones of the same species that are less viable. And
That's
in the
right.
row ones, you're more concerned about killing the weeds that are competing with the crop you are interested in. Is that correct?
Absolutely. Absolutely.
Okay, so with going back a little bit, so with Blue River, they were starting with these non-row crops, and then feedback from customers was, we are interested in row crops. Continuing from there, what happened?
So Blue River had to make a shift, right? The technology, the actual, even the agronomical. When I say agronomical, I'm talking about,
it's a cool word.
The word, the way that you do something in agriculture.
Is it like economical, but for agriculture?
So for agriculture. So in this case, we have all these seeds that are out there. We want to get rid of the ones that are not viable. So how do you do that in a way in agricultural? And so and there's multiple ways you can spray herbicide. You can go in and dig up the ones that you didn't want, or you can even apply fertilizer. And that's what Blue River did. They applied fertilizer. And what happens if you apply too much fertilizer to a plant, it'll explode it. It'll just grow so fast that it can't handle itself, and it'll explode it.
Really?
The nice thing about that is now that fertilizer is in that soil,
it benefits all the other plants.
That makes the one that is viable, that one now can grow stronger because now you have made a very fertile environment. The ones that were weak exploded, but this guy that is not weak took that fertilization and used it and grew better.
So again, not knowing much about agriculture, why does it? So it explodes, it grows too fast, and then it can't support that or something. Why?
That's right.
Why does it die because it grows too fast? I guess
because it's just the fertilizer is a kind of how do you put that? It is something that encourages the plant to grow very fast, but the plant has to be able to handle it.
Does it grow too? Is it like a startup in some sense that takes venture capital funding, and it basically gets a huge investment? But if the money, so you grow rapidly, and then the expenses are coming, so then it's basically.
Essentially, it is you're going too fast, and I would put it similar to a startup. Similar to a startup, you're going too fast, but you don't not the funding, but the but you don't have the infrastructure. Resources. You don't have the infrastructure to handle it, right? So that viable crop, right? That one that is like is gonna sustain. That one has gained all the things necessary to reap the benefit of that fertilizer. These other ones are in such a non-capable state that when you feed them fertilizer, they grow so fast, but they're not capable. They're not ready for it. In other words,
so they grow before they're ready, and they overextend themselves.
That's right. There you go.
They die.
And it's just too much. It's just too much, right? It's just through. And the guy that's like, hey,
Napoleon now or something like this, having too big of an empire, and then it collapses.
It collapses, right? It collapses. Okay. You could think about it as I have too much resources that I cannot contain it. I cannot hold it within my infrastructure. So I need to. What happens is it just explodes. Whereas the plants that can handle that, they take it in and they use it and they grow, which is what you expect when you get like an investment or an increase. And it is a ridiculous amount, right? It would be like, you give somebody who's never had a business before in their life, 30 million, right? Like they wouldn't know what to do with that properly, right? They would explode.
Gotcha. It's like getting rich quick kind of thing, and then it just goes away. Okay.
And have no ability to deal with it, right? And no ability to deal with it.
Yep.
But the thing about that is that money doesn't go anywhere. That money is still out in the environment,
it's still in the system,
and that next crop that's next to those plants that get killed that way reaps the benefit of it. So you're fertilizing. So it's kind of a two-pronged process. You're going to fertilize your soil anyway because you want your plants to grow, but the ones that are not viable, you fertilize it to the point where they are going to die. But that overlying fertilizer still stays in the ground. Then allows the ones that are not going to die to grow, to flourish, to be better. You harvest those. That ground is still very fertile. All those resources that you dump in are still there. You can go plant again next season. The ground's fertile. It grows again. You do this process again. So you're kind of, it's kind of a cycle of fertilizing
each
the ground,
season.
but also getting rid of
The weeds
the
by making them overdo
the
it.
crops that are not gonna make it right. And you give those guys an extra shot so that they're not gonna make it, and then
Is
but
this
you
so? Are we
leaving the
speaking
ground
about
fertile.
row crops where it's weeds that are competing, or are we speaking about non-row crops,
So
or
that was
both?
non-row crop. So in a row crop, it's a different environment, and that's why I was talking about agronomical
Ah,
tools, right? And so in a row crop, fertilizing the weeds is not the way to go, right? You don't want the weeds to grow. You
yeah.
want to deplete the weeds. You want the
Oh, so
weeds to
that
be
was with
removed.
the, I see. So that was with the non-row crop, what we were
That's
just
right.
talking about with over-fertilizing them. So you do it to the non-row crop that are not promising, and thus they grow too fast, then they explode and die. Not literally explode, probably. But for the row crop, you're saying now we have a different strategy. What is that?
That's right, and that's what I was talking about, the agronomical strategy, right? In agriculture and in plants, you can imagine there's the variety of plants in the agricultural world is just as varied as humans, right? There's
Hmm.
just life itself is just so varied, and
Yep.
it's even more so in the plant world, and so different strategies are needed for different types of plants that you're growing. And in a row crop situation where you know the seed is going to take, you know that when you plant that seed, it's going to come up and it's going to come out of the ground. It's just a matter of how much yield you're going to get from it. The
Yeah.
strategy there is different because now you're not competing with others like seeds. You're competing with weeds,
Weeds. Hmm.
completely different plants that are trying to suck the resources out away from the plant you're trying to, the cash crop is what we call it. And so in that situation, you actually want to you want to alleviate that weed. You want to alleviate those plants,
Hmm.
and that is not
Alleviate
a
is a funny
natural.
word for that
It's not right.
because
It's
it's the
alleviate.
problem. You're alleviating the problem, and
It's
thus
right.
you're killing the plant. I see. It's
Yes,
just an
right. So
interesting
it's
word to use
killing the
for it.
plant. It's killing the plant. It's making sure that plant. So
Doesn't consume
I say
additional
alleviate because you
resources.
never really kill it. You never
Oh,
really kill it, right? Like
but
those
you remove it as
plants.
a competitor
That's
for
right. There you
resources.
go. There you go.
Ah,
So you think about plants, you think about life. Life always wants to persist. It
it's hardy.
doesn't really die, right? It's hardy, and yeah, that's absolutely true. And in row crops,
Only the
the
cash
biggest
plants
problem
die occasionally. The weeds
you
never die.
we purposely harvest those, right?
Yep.
But the weeds are just there. And the interesting thing that happened, so just go back, 30 years, they had what Roundup. They had chemicals that would they had their crops genetically modified. You could
Hmm.
spray the entire field. We call that broadcasting. So you spray the entire field with herbicide.
Hmm.
The plants that you were trying to keep were genetically modified so that herbicide did not kill that plant, but it killed everything that wasn't genetically all the weeds that were in that plant that had the
Yeah.
genetic modification in it to that
Hmm.
herbicide. And so all those plants, and what you would see is you would go down a grower's field and it would be what we call clean. You would only see the crop that the grower was trying to grow,
Hmm.
and there was
Everything else was
nothing else
dead.
but dirt.
Yeah.
Everything else was dirt in the field or soil. Only the crop was there. And that was the American agriculture for 30, 40 years,
Huh.
using these genetically modified plants.
Okay.
What happened was over time, and you talked about life and how hardy it is, you
The
killed
weeds
all of the
adjust.
you killed all the weeds that were susceptible to that herbicide, and the only ones that persisted were ones that were able to fight through the herbicide.
Yep.
And so now they built up a herbicide resistance.
Yep.
And
We're
so
in an arms
now
race.
they are the herbicide resistant plants are the only ones that are reproducing. So now when you reproduce, you're only reproducing herbicide resistant plants. And that is
Crazy.
causing a huge error, a huge problem in agriculture because now the plants are being able to build up resistance faster than the engineers can build up new technologies to actually kill those resistant plants. And
Wow.
so now you're having what we call unclean fields where growers are spraying, they're planting crops, and these herbicides are resisting it. And so now they have to come up with something different chemicals, different
And
ability to get rid of
that's
those
in a
plants.
timeline of like 30 years, you said. So the
Yeah,
plants
so 30 years we've been using
of you
the
Roundup
herbicide. We've been using herbicide.
or
I would say
herbicide,
in
yeah.
the last 10 years is where they've really become. Maybe in the last 5 years is where they really become
Hmm.
prevalent herbicide resistant weeds.
Wow.
To the point where they're starting to, like, hey, the strategies that growers use, and there's multiples. There's
Hmm.
herbicide. There's what we call a field fighting. You go and you kind of just trim up the dirt in the row to
Yep.
kill some of the weeds.
In
There's
between.
multiple techniques, but
Yep.
but like I said, alleviate the problem. You want to give the crop that you're trying to grow and get yield from, the one that you're trying to sell, the best opportunity to win in the competing of resources that are in the ground. So you
Hmm.
want that crop to get as much of the resources as you can, and to provide the weeds and other things less resources so that they die off.
This may be a silly question, but why not just make an incredibly resource dense field um, and have a bunch of weeds, but also have your cash crop? This kind of thing.
Because the weeds are they're called weeds, right? They're just plants,
Yeah.
but we call them weeds.
Undesirable, not cash plants.
And the reason why is because they're very effective in sucking the resources that you want. Your cash crop
So they
will
kill the
not yield.
cash crop by
They will take
starving it of
over.
resources,
Yeah.
and they grow way quicker and things
They're
like this, maybe.
exactly their genetics are so that they would take over, and then
Ah,
those viable crops that you really want, that you want to keep, which when you think about you just think about society, you think about just biology again in the world.
mm-hmm.
Things that are valuable to humans, particularly to humans, are things that are scarce. So things like cotton, soybeans, plants that you could eat, plants that you could reap. It's something that was
Yep, make
beneficial to
something
us.
with, do
They,
something,
they
yeah.
they they weren't just plentiful everywhere and everybody could just have it and it was just great. In order to make that, especially for the population of the world today, you have to very strategically go and grow it. Right. That's kind of how the world got as populated as it has, is because we no longer just kind of go hunter gatherer and just go find where the right stuff is off the tree as it grew naturally. Because in
Mm-hmm.
order for it to grow naturally, it would have had to been in an environment naturally that just didn't have enough competition with all the other fauna in the area, so that that thing could grow. We're very specifically saying, hey, we like apples, we like strawberries, we
Yep,
like soy. So
cotton, soy,
so
whatever else, yeah.
so we have to definitely beat off the fauna that naturally just grows, that
Hmm.
naturally would just take over. It isn't necessarily beneficial to us, right?
To
It's just
us.
it's right. It's plant life, but we're trying to specifically grow plant life that's beneficial to us, and all the other plant life around is like, hey, I want to use this. I want to take this spot up too,
Yeah, you're
and they're and
fertilizing it
they're
and making
and
it
they don't
really
need as much
nice.
energy, right? The reason
Yep.
why those things are valuable to us, because fruits and things like that need a lot of energy from the ground, and
Oh,
so it's easy for these other things that don't bear fruit, that don't give us any benefit, to grow and rapidly take over the land, because they don't need a lot of energy, because they don't provide anything of value to us. Fruits and
yeah,
you can
there's
think
nothing
of
we can harvest from
yeah,
them,
yeah,
really.
exactly. You can think
So,
of the things that humans care about as the fruit, right? And those things take energy. The things
yep.
that don't provide fruit, we necessarily don't take a lot of energy, and they're prevalent. They're everywhere.
Yep, and by fruit, you mean anything we can harvest, right? So like, I don't know, cotton, like the seed probably is not a fruit, but you mean that as in something we can harvest and then use. Is it correct?
Yeah, absolutely. So the bulb, the right,
Yep,
the
the fruit of the
flower.
labor.
There you go. There you go. Yeah, yeah.
Gotcha, gotcha. Okay, and then so what was the strategy for row crops for this kind of thing?
So the strategy here for row crops is to, and it's a cool thing that Blue River did, is because you're talking about agriculture, you're talking
Hmm.
about a customer and a market that's been around since the beginning of the United States, right? This goes way
Hmm.
back. John Deere's been a company for hundreds of years in the
Yeah,
U.S.
that's awesome.
And so the agriculture is a mainstay in the United States, and that customer and that market is not very open to drastic changes. they've been doing things the way they've been doing it for the past 20 years. You're not just going to come in here and say, "Hey, I got this spaceship," or "I got this cool technology that's just going to make your," they're very adverse to those kind of things because they know what they've been doing. They've been doing that for a long time, and they're very adverse to very crazy out of the box changes. And so what we did was, okay, you already use herbicide. You're already spraying your entire field with you're broadcasting your entire field with herbicide to cover every acre, right? Like, so if you got a 1,000-acre field, you're spraying the entire 1,000 acres with herbicide, even though there's only weeds in certain pockets of that field. So you're just spraying everything. What Blue River did was the cool thing we did that was novel was add a camera to that sprayer, the same sprayer you've always been using, the same technology you're used to using.
So you like point it at things?
We added a camera. The camera can look at the ground. It can tell where the weed is exactly located, and then we spray only the weed. And instead of spraying the entire field, you only spray where the weed is.
With the herbicide?
With the herbicide. That's
okay.
Correct.
Gotcha.
And so now you only kill the herbicide. You only spray where you need to spray the herbicide. And you can imagine, like, you're reducing the cost of the grower. You're reducing the herbicide that's in the ground. Causing environmental impact, and so now then you give the grower the opportunity to use the same technology that he's used to using, but being more effective and more efficient. And you give him the opportunity. I was talking about the herbicide-resistant weeds. You give them the opportunity to use different chemicals,
they can
right?
Switch it up, yeah.
That's right. Because before you sprayed everything, so you have to use genetically modified herbicide in crops. Because you want to be able to spray everything. You don't want the crop to die. Now, if I can just tell you, I can just hit just the weed and not everything else. Now you can use different chemicals, different herbicides that will only target the weed. There you go.
Now, do you need to use genetically modified crops for this because you're killing things in the same field with some sort of herbicide? Or, like, do you want them to be slightly resistant to it so that something in their system is not, like, say you spray this one weed in this field of cash crop, and does that impact negatively the cash crop that's around it? Or is it a small enough and precise enough dose that it just kills the weed and doesn't damage the crops? Or is it a trade-off between the two?
So so nothing's ever perfect, right? So it depends. Depends on the cash crop you're using. Some cash crops you want to be able to genetically modify them so that you can spray the crop as well as the weed. And then depending on the cash crop itself, you don't want to spray it at all. You want to spray just the weed. And so, and you think about, the situations and the variances of fields, the variances of crop types, the variances of weeds. You have all those different things, and depending on the situation, you want to apply a system that works for your situation, right? And so the focus of Blue River and John Deere, overall, is to give the customer the ability to tailor their system to their situation, and give them a system that effectively will work for them given the situation. So some situations you can genetically modify, spray just the weed and a little bit of the crop, and it doesn't hurt. Some situations you want to be able to spray. You want to target just that weed only, and you don't want to spray the crop at all.
One thing just to clear up, would you talk a bit about the relationship between Blue River and John Deere for this? Because we mentioned it, but just to explicitly talk about how they are related.
So Blue River and Blue River was around, right? There was a startup company. I talked to you about the founders.
Yep.
And eventually they, not just John Deere, but other, agricultural companies were interested in purchasing Blue River. And I think John Deere won that war, the bidding war, if you will.
Nice. It's nice to have a bidding war for these things.
Sure.
That's
sure.
cool.
So the use of the technology and the viableness and the need, I think, is real. Like, it is absolutely 100% a real problem that's happening across the world, and it needs to be tackled. It has to be tackled. And
to
so,
keep feeding everyone, kind of thing.
John Deere was one of the first people to say, "Hey, this is not even just this particular problem with the
The row and
herbicide
non-row.
resistance,
Yeah. Oh, yeah.
just applying artificial intelligence and high tech things into the agricultural world. That's a new thing, right? Like these companies, John Deere particularly, have been operating and using machines for hundreds of years, and they have grown in technological advances, but they hadn't been implementing artificial intelligence and high definition cameras and very high power computers.
Yep.
And so making the next step, I think John Deere thinking about making the next step, and where does agriculture have to grow, and for the future to continue to sustain and to continue to maintain, for the population that we have on this earth, that these technologies need to be integrated into agricultural industry. And saw Blue River as, with the way that we went and tackled the problem using AI, using very high performance computers, using, advanced technologies, and robotics, they saw that this was a nice integration into their company.
Gotcha.
To give them the ability to use robotics to roboticize, if you will, their machinery that they already had, that they already built, that they already make.
Gotcha. So then, so you were spraying herbicide on the weeds in a row cash crop field. Is this kind of or I guess where does Blue River go from there before being acquired by John Deere? Or is that kind of the core competence of the company?
So we essentially, the mentality is give the grower the plant by plant knowledge so that they can make a smart decision, right? So we have cameras, we have artificial intelligence, we have the ability to make real time decisions using robotics, right? So we use robotics to be able to say, hey, real time, this is what this plant needs, and that was Blue River, and it still is. It's Blue River's, driving force. You can look at a plant real time and decide right there, what does this guy need? And that is, when you think about any person who's in agriculture or into, planting biology, they will tell you the plants that grow the best are the ones that are taken care of individually. This plant needs this. This one needs a little bit of pruning. This one needs some fertilizer. This one has weeds growing around it. So Blue River was allowing you to do that at a scale level. Not your pot in your house. Where you're kind of hand doing
in
things
a field.
In a field, thousands of acres with a machine. That you can just kind of let do its thing, and you as a grower don't have to sit there and do that meticulously.
And is it only spraying plants? Is it also trimming or any of these other things that you've mentioned?
So you can imagine the technology can be advanced. The original, this initial induction into the market is spraying plants for herbicides because that is a very prevalent problem, and it's something that Blue River was already doing. But you could imagine,
and it's cool because you can retrofit existing systems, so that's very nice. Just
retrofitting existing systems, developing new systems that are very optimized, and then extending the seed and sense technology, kind of like we talked about this a little bit. See and think and actuate your podcast. That's exactly what Blue River, long term, overall, that's the goal, is to be able to sense the environment, do something smart, and then actually do something smart to the ground or do something smart in the world.
Sense, think,
so
and
think about it, and act about it. This is exactly what your podcast says. And
that's why we chose the name.
You think about agriculture, all the different things that you have to do. You have to plant the seed. You have to take care of the seed when it's down in the ground. You have to fertilize it. You have to weed it, and then you have to harvest it. And then you take it from harvest, and you have to get it out to the market so that it can be sold. So there's just a lot. There's a wealth of tech. The agriculture industry is just, I won't say behind, but just has been doing things a certain way for a long time, and is a fertile
There's
ground
entropy.
for new technology, for new ways to go about to bring that sense and think and actuate, paradigm into that world. There's just oh my God, there's just so many different ways.
Lots of opportunities. Yeah,
that's absolutely right. John Deere, and Blue River being acquired by John Deere just gets us right in the forefront of it, because that's one of the biggest agriculture companies in the world. And they do everything, from planting to harvesting to tilling the ground to getting it prepared, and as well as other industries, construction, forestry. So
what do you mean? Oh, are you saying John Deere does these, or
yes, John Deere. And so Blue River, bringing the sense and think robotics kind of a mind frame into an industry and into a company that already has its footprint across the world and all established. That's right on.
And they're domain experts at the actual markets that they're servicing. So agriculture, and then the other ones you mentioned.
That's right.
So then partnering with them, where you guys you're helping on the sensing and thinking side, and then they can kind of use their existing systems or retrofit your systems into it, or even add your systems, design your systems,
integrate them. Exactly. So really at the foundational level, right? Let's develop new systems, right? Let's rethink how we do this. We know how we do it already, right? But we did it already with previous experience. Now let's bring in this new technology and let's rethink how we could do it. How, if we bring in different sensors, cameras, lasers, sensors, smart algorithms, and different ways to actuate and different ways to go about doing something, and now change the future, right? Like you could just think about all the different ways that AI, robotics has changed the world and is going to continue to change the world. Before you have to have a human in the loop, right? You have human beings,
or humans just doing the task, literally
doing the task. And now you can provide a smart machine that can do this task.
So one person can do a bunch of fields and effectively have a bunch of like robot workers on the tractor doing the hard manual things.
Absolutely.
And very focus intensive.
Absolutely.
So, let's see. And then, so with Blue River, so I'm just curious, I guess, how was it, you were around when John Deere purchased Blue River, correct?
That's correct, yes.
How have things felt to you as things have changed with that? Like, how has the focus changed, or what kind of problems are you guys working on, or what's interesting about being acquired and the process of that?
I think it's very, like, for me personally, it's been very interesting just to see a company transition from, very, startup, environment, get out there, fire under the belly. We got to make something. We got to continue to, develop this product so that people are interested and grow. Mm-hmm. Until now, you've been acquired by a company that totally has the resources to make sure that you grow, but we need to grow it in a direction that is actually going to be viable and actually going to be, a product that's actually going to be put out to market and customers are going to receive and use. And having all of that expertise and the knowledge of all of those years of John Deere manufacturing agricultural sprayers and any piece of agriculture melded with the high technology, and you could already think that there's going to be a lot of challenges, right? That's it's not necessarily two different worlds, but kind of different environments kind of have to mesh together. And I praise John Deere for giving us the ability to kind of keep our autonomy as far as developing the technology and going as fast as we can to continue to develop it and grow it and make changes as we need, but keep us kind of, I would call it, what do you call that? Leadership and management. John Deere has this, the division, right? This is where this thing needs to get funneled into. You guys have the ability to do whatever you think needs to be done in order to accomplish this goal here that we're trying to accomplish. And the goal is big enough and broad enough, right, that it encompasses all the things that they're doing, right? It encompasses not just the sprayer part, which is just this one part that we're working on, and probably the first thing that we'll roll out, just because Blue River was the most mature in that area.
Yeah.
But we're already developing other areas,
Cool.
and so John Deere just has the great vision, has the great wherewithal, and I think because they've acquired companies and just have all the experience, right? The company's been around for years. They know, the ability and the way that they've went about the acquisition after it happened, and the way that they're slowly bringing us into their environment, into their world, but still allowing us to be Blue River, I think is great. And I think it's just kudos to them, because they could have totally just came in and say, "Hey, boom, we bought everything, we own everything. You guys are going to do this like how we said," and they didn't do that. They said, "Hey, they appreciate it. You guys have something special here going on. We don't want to affect that.
Mm-hmm.
We want to allow you guys to continue to do that, but we want you to do it in this direction."
Yep.
And the directions aligned, which I think is another smart thing on them. And I think with Blue River as well, the reason why we got acquired by John Deere is because the directions aligned.
Very well.
And so it was like, yeah, this is going to work, right? This is going to work. Kudos to our CEO for
navigating that.
Because absolutely. Making those things happen, and he's still around, right? Like our CEO's still here. Jorge is still doing the job. He's still managing. He's still doing very important things for us. Yes. And we're continuing. This is working out pretty nicely, actually.
Hell yeah. What was the timeline? So founding of Blue River, acquired by John Deere.
We got it founded 10 years ago. That's what? This is 21, so 2011?
Guess so.
And then we got acquired by Deere in 2017. So that's what, 6 years after the founding? They got acquired by Deere.
Gotcha.
And so here we are, 2021, 4 years after acquisition.
Still going well.
Still going well, and probably going to bring the first product to market 2 years from now.
2 years? Can you talk a bit about that, or is that a secret?
I can say that it's coming. That's about
That's it.
That's about it.
Okay.
Not any details, but the first product is coming soon.
Nice. That'll be exciting. So then, can you tell me a bit about your experience? So you quality manager, quality assurance manager. Can you tell me a bit about what that means? And I mean, I've been in academia most of my time, so we don't really have this. Would you tell me a bit about your job as a quality manager?
Absolutely. So quality manager is an essential part of the business. Is to make sure that the customer receives value in that product, and that the product that they get is what they expect. Not only what they expect, hopefully it exceeds expectations, but first and fundamentally is what they expect. And so it's making sure, I think about it this way. You can have the startup mind frame, and just really just going. You're really just going.
Move fast and break things? Or
move fast, break things. You put something out there, but there's all kinds of bugs with it. And depending on your market and depending on the customer, you think about these phones, 20 years ago, and they had all kinds of bugs and issues with them. But the customer you were dealing with was okay with that, right? Like, my phone. They were early adapters. Oh, it's okay.
Yeah.
I got to do this thing, or I got to press it 2 times this way and do this thing that way, and then it finally works, right? So that was fine for that environment, but for our particular customer, agriculture customer,
they want it to work.
And John Deere, name recognition, it just works. John Deere has the reputation and the clout that when I buy a John Deere, it works out of the box. I turn the key, it does what I want it to do, and if anything is wrong, they fix it, Johnny on the spot, no big deal. High quality, I pay premium because it is the high quality product. It's the best, right? It's one of I would say it's the best, right? It's the best that you're gonna get, and so how do we maintain that, right? How do John Deere has maintained that over years, over centuries. How do we maintain that? And so my job is to allow Blue River developers the ability to continue to grow, to continually to develop this product, to continue to iterate and make it better. The Bay Area, Silicon Valley, quickly iterate, hurry up and fail. But when we release something out, to the customer, it has that John Deere quality. It has that this is going to work. It is robust. It is going to do what you guys told me it was going to do. So I'm the kind of the gatekeeper. I'm like, yeah, go develop all that cool stuff. Go get in the lab. Go write your code. Let's get out here in the field. Let's go test it. Let's come up with all the cool things that we can. But this is what we can release. This is what we can give out because it's ready. And if it ain't ready yet, hey, it's not ready yet, guys. We gotta go back, rehash, reiterate. And so I want to allow those guys the ability to continue to reiterate and continue to develop product, features and things, but only allow out John Deere quality features that are ready to go. And so that's my cool job. Yeah.
Hell yeah. So what does it look like in a little more detail? Is it like when I think of quality assurance engineers, I mean, I'm at Open Robotics and we have a lot of software. So quality assurance for us means like writing software tests or making sure we have certain amount of code coverage with our tests or whatever, these kinds of things. It sounds like your work is a good bit more applied, as in like go in the field. Can you just tell me a bit more about what it involves?
It's that, right? It's that, but you said exactly. It's definitely unit tests, code coverage,
in software?
Those type of things in the software stack, right? But it's not just a software piece of equipment; it's a robotic piece of equipment.
Yep.
And so it has to actually perform out in the field. So there's more things than just does the algorithm behave the way we expect, but does the mechanical devices behave the way we expect? Can the cameras and the wires and the things hold up to the environment that we're going to throw them in? And again, I said earlier about we gave the customer the ability to use a platform that they were already used to using, and they're already used to using it a certain way. So they're already used to having the sprayer that I park out on the corner over here, and it rains on it, and it snows on it, depending on what part of the country you're in. Yep. And it does, so the environment does its thing to it, but I can turn that key next season, and it goes and it does its job. So making sure that all of the pieces and all of the parts come together, the integration. Gotcha. in a way that when that customer exactly my North Star is the customer turns the key, the thing does what it's supposed to do, or at least tells you, hey, you need to go do something. You need to go do something, right? Your camera cables have fried over this past season. Go replace them, And so making sure that all of those things are there, the quality is there in and of itself, and when it isn't there, it is very obvious to the customer what it is they need to go do to fix it. And so it's unit testing. It's code coverage like a software company that has those features, but it's more customer focused. It's more customer focused. So we definitely have to go out and test it on the machine and give it real machine time to see what the customer is going to experience and give them the best experience we can give.
Okay, I'm curious about the hardware side of this. So with software, if I write tests to constrain my code to make sure that it's working, the tests fail if the code is not working, and then I just run these frequently and I can tell if my code is working over time. What do you do? So that to me is clear for software. How do you test hardware to make sure that, or even like hardware and software and their integration together? How do you test this and make sure? Yeah, no, I'm sure. I've seen like with Boston Dynamics or some robotics company, they'll just have their robot do the paces. So they'll have it run and move continuously for a week or something like this. But can you speak a little bit about this? How do you do physical quality?
It's essentially the same, similar things. I mean, I won't get into the details of exactly how,
Yeah.
but it is something along those lines, right? We run that system through the paces, if you
Hmm.
will. I can't give you all the details because it is essentially the John Deere name. The reliability and the the confidence you get from saying that I bought a John Deere and I know this thing is going to work
Hmm.
is it's part of their secret sauce. It's part of their this is how we got to be who we are. And I would say this: the nice thing about being acquired by them is that we were able to be brought in into their process of how they ensure reliability and quality to the customer. And we could add that in, and I think that a lot of startups, not every startup, there's always going to be great startups. They're always going to hurry up and
Hmm.
fail and then figure out the quality part later.
Yeah. Hurry
They're
up
going
and
to do
fail is
that.
such a funny
They're
way to
going to do
phrase it. Yeah.
yeah, they're going to do it, right? They're going to figure
Yep.
out, oh, that didn't work. Change it up real quick. That works now. Change it up, and depending on the customer base, you have a lot.
Yeah.
You have a lot of room to do that, especially if it's new technology that's never been out there, and your customer base is like open to it.
Hmm.
Our customer base isn't so much open to things that don't work. It has to work,
Hmm.
and John Deere is very keen on that, and so I would say they did a good job of bringing us in, allowing a startup to see how do you transform from making this cool technology that works, 80%, you could talk about when you develop something, it's that 90 to
Uh,
95% edge cases are the make or breakers, right? You can make something that works 80, 85% of the time.
hmm.
The 90, 95, the 97, 98, those ones are your problems that take the most time, right?
Hmm.
It's those edge cases. And
Yeah.
John Deere has a method for that. And
Hmm.
so we work it, right? We continue to work it. We continue to develop the product. Um, I can't get into any of the details other than that, like you said very clearly, is that you continue to test that system, and
A
you have a
lot.
method. You have a method of doing it so that you
Yep.
know that when the time you release it, it is ready.
Yep.
It's ready for the customer is ready to accept it. Is it not? Is it perfect? No. There's no perfect. There's no perfection.
Oh, of course. Yeah.
But
Getting to ninety
you
nine
have all
point
the
nine nine
big
nine nine nine
yeah,
whatever.
you have all the big kinks out, and then the rest of it is there's a system to handle the rest.
Hmm. So is there so it sounds to me like a lot of your job might involve figure making decisions about what can and cannot be included. Can you talk a little bit to this? I'm sure it has something to do with the John Deere process, but also it's a value judgment on your side, I imagine, where you're going. We need it to be good for this temperature range or whatever it might
That's
be.
right. That's right. It's essential, right? Like there's specifications, and there's certain things that are go no go. I try to be very clear on that, and the other part of my job is when that isn't clearly defined. Some things are just clear. This is
Huh.
good enough, and this isn't. And then there are
Hmm.
some things that are like, okay, this is a gray area. We don't have a really clearly defined
Can you give me an
uh,
example of a
parameter
gray
around
area?
it. So I don't know. Let's think about the technology, right? Think about artificial intelligence.
Hmm.
Artificial intelligence, is probability. So you have these these algorithms and these metrics that say, okay, hey, if we're about this percentage good on our detection
Ah,
of
so
a
it may be like
thing,
I'm 95% confident that this is a tomato plant, this
that's
kind
there
of
you
thing.
go. I'm
Okay.
95%. Is 95 going to be good enough?
Hmm.
Do we need to be? Do
Or
we really need to
80
be
or 70 or
97? Or is that where's that number? And that's hard to say. And you think about the world, right? These machines can be anywhere in the world. That variance changes depending on where you are. So
yeah.
if you're over here in this part of the country or this part of the world, that's good enough. And the other parts of the country, the world, or particular, actually even the particular actual grower, that's not good enough. I need this thing to be this well, or otherwise I'll just go buy the other thing.
How
And
does this
so
work? Because so I'm thinking like, okay, considering you guys are in like all over the world, you have machines all over the world. Um, I'm imagining that if you're using um, some sort of like probabilistic machine learning AI thing for identifying plants or weeds, there's probably a good amount of variation in the weed. There's a good amount of variation in the type of lighting you get during the day. There's a good
Sure.
variation in the amount or like the color of the soil or the makeup of the soil or anything like this. And this would probably make it, depending on the method you're using, a good bit more difficult to come up with metrics. So I guess, yeah, this would be a good gray area
That's
example.
right. That's exactly why I brought it up because it
Okay.
depends. It depends, right? It depends on like all those things you said, right?
And
The
probably way
soil,
more
the
factors too.
environment, the
Lighting conditions,
what
yeah.
condition you're in, and I think
Moisture
the important piece that I talked about with quality is under letting the customer know how what quality you're getting, right? And
hmm
so being able to communicate that, I think that's in key. I think that will be key in the future of robotics as well as we continue to develop the technology. There will be situations where there's an expectation, and now we cannot guarantee you what you expect. And so, we tell you, hey, you're in a situation now that we're using fuzzy probability mathematics, and
Yeah.
your numbers are starting to come below a threshold.
Is
And,
that
and, and so now it is up to you as the end user to say,
is that
hey,
worth it?
can I keep going this way or no? And
Is that defined?
I think that's going to be, I think that's going to always be the case for a
Yeah.
long time in robotics until we can get all the edge cases out of a particular application.
hmm
And well, how many robotic applications do we actually have in the world? There's not a lot of them. And so as we develop these new novel ones, they'll need time.
To mature even more
Hmm.
and become more reliable.
Hmm.
Okay. Does it mean you go and test the robot system in a similar environment to what the customer is and then measure how effective it is and then report that to the customer? I assume it's not like a real time, this is how well we're doing um, system when you're talking about telling the customers quality information.
So it's both.
Oh, really?
It's actually there's some real time to it, right?
Hmm.
There has to be in our particular, it's a robotic system. You
Yeah.
have to let the customer know like as real time as you can that
I'm just imagining like,
you're not behaving the way that you would want to behave.
yeah,
And so
I'm
you got to
imagining.
be able to give them that. You have to be able to give them that.
Okay, because I mean, I guess I'm a little confused because I'm imagining like a robotic system going and spraying plants, and maybe it says we hit 80% of the weeds. But the thing is, at the time, it thought every one of which it sprayed was a weed. So 20% might have been the cash crop or something like this. So
So
if it's able to
the
label,
secret sauce I can't give you, but
ah,
what I can tell you is that you have to be able to allow the customer to know that your system isn't behaving the way you expect it to,
oh,
right?
maybe it's just being aware of how confident you are about the things you're doing and reporting that.
Exactly.
Ah,
So yeah, exactly, right? Like
I see. So it's
if
confidence
yeah,
based, not
it,
outcome. You don't have any real labels for what you're doing. Gotcha.
well, it depends, right? It's a combination. I can't get into all the details,
Yep.
but I will put it like this: there's both components. There is a real world component that
And
is
you're
real
testing
time, and there's also introspective after the fact.
hmm
That you can go back and look,
after the fact.
and then you can combine, right? And
Yep.
so I'll put it to you like this: if you've ran over a field once, if you've already kind of been through an area once,
hmm
and then you go back through it again,
Ah,
that provides you ability to make different kind of
introspect.
decisions.
You get to
You
see
know,
if the weeds were all killed or if there's a bunch of them still or whatever.
where the weeds are, what's the density of them,
hmm
how the machine's behaving at the time when you go through that part of the
Yep.
field. There's lots of different things.
Cool. Okay, I didn't consider the kind of temporal part of
There's
it.
lots of different things.
That
Yeah,
makes
yeah.
sense.
We definitely do both. I would say we do both something real time because you want to allow the customer to know right away that, hey, you're not in a great situation. And but then there's also like, what is the situation exactly in that area? What is actually going on? Why isn't that a great situation? And then how do we correct for it? How do we make it better? How do we improve upon it? And so, yeah, providing the customer with the ability to do that. And so those are the two, I would say those are two things that I constantly have to make sure that we're doing. And you know, it's cool because we're developing both, right? We're developing both of those infrastructures now, real time, like, you know. And so when that product gets released, you then present the customer ability to do both. He can say, hey, right now, this is what's going on. He can make a decision, or she can make a decision on what do I want to do now. After the fact, they can come back and say, hey, that's what happened at that time. How do the next time we go through that situation again, I'm better prepared and better to make a better decision, you know, with new information. And then, you know, that turns on another, you know, opportunity or ability in ways to tackle it, you know, versus the real time. Real time, you're making a decision right now, you know. Planning ahead of time is always better, right? If you can plan ahead, that's always better.
Now, would you talk a little bit about doing work in the field for this kind of thing, or like getting out in the field and testing your systems? I think that's a very interesting part of what it sounds like your job involves.
Yeah, absolutely. So we had to get out in the field. You know, I got a team of people, you know, and also in coordination, not with just the QA team, but the field team that's always out on the machine, that's always out there, and being able to understand how the machine actually behaves in the field. And so, you know, that it's not the same thing as like an iPhone or you know, a piece of software that's presented in a web server. It's an actual piece of equipment that's put in the field, and another customer uses it, you know, puts their hands on it, and actually gets out there and utilizes it. So it's very valuable to me to get the customer's input, the customer's point of view, the novel use cases. So putting out something in the field with a customer, you know, you have in your mind as an engineer and the engineering team, this is how we think we should be using our product. And the customer will just say, oh, I can do this, this, and this. And it's totally something you didn't even think about. You know, you didn't even think, oh, wow, I didn't know that you were going to go do this, because, you know, we didn't design it for that, but it can totally be done in that way. And and so that's always cool to get their point of view, to get their use cases, because then we can start to think about, oh, wow, this could be used this way. We didn't even think about that, but let's make sure that way works. Let's make sure that way works, because now we know, right?
That they want to use it that way. Yeah,
they want to use it that way. Putting it out in as many, I think any company wants to put their product in as many environments and use cases as they can to get the 97, 98%, because you don't know, right? Somebody's using it this way. You have your prescribed way you want to use it. And you don't know, where those edge cases are in your software stack, in your mechanical stack, of what's, where did we break down at? Where are we not good enough at? And so if you don't get out there and you don't give yourself the ability to do it in as many different environments as you can, you're going to find an environment that you didn't prepare for, that you're not capable of handling. And you'll just have to figure that out later. So we're keen on, and then the nice thing about being acquired by John Deere is we can go lots of places across the country and across the world to make sure we're getting, the big swaths of use cases.
Gotcha.
Right.
Cool. Let's see. Blowing up a little bit, or going up a few levels, what do you think, where do you think robotics and agriculture is headed?
I think, robotics in general is the future of all industries. Agriculture is going to totally, 20 years from now, it's going to dominate. there's gonna be these machines will be automated and self-sufficient 20, 30 years from now.
Wow.
A grower will be able to say, hey, I want this to happen on my land, and it will happen, and there will be very little human input. There'll be some spots for human input, but unless someone from Congress or somebody artificially removes
Restricts the progress in that area.
it's going to grow. I mean, this is the only way for these things to grow, right? Like there's ton of machines, there's ton of land. We have to feed in a growing population.
Bunch of people, yeah.
We have to do that efficiently as we possibly can. We have to take in as much information as we can about the ground, what's going on that ground, what do we need to do, how do we reap the best, to get the most out of it, and then get it ready again, season after season, year after year. And we've been doing that as humans with a lot of human input, and I mean that works. But in the future, it's gonna be less human input. It's gonna be a systems input because we're finding that the systems can remove that human input and do it better and more efficient. And so, if anything, if history says anything, when we find more efficient and more effective ways to do something, we do it that way.
Oh yeah, for sure. I'm curious to where you get the number of 20 to 30 years. Like what?
It's just the technology growth, right? Like it's the and I could be off, right? I'm giving myself buffer there.
For sure. I'm just curious to like order of magnitude. How do you?
It's the technology. It's the ability. So AI is very. I won't say it's infant, but applying it into real world problems is still fairly new.
Yep.
There's some areas. But we're talking about agriculture. Agriculture, I think, is still fairly new. Like I think we're at the cutting edge. I think Blue River is probably
that's a cool spot to be.
right at front, right? And so where does it go? And what are the new things that we're going to learn, and how are we going to apply the AI and the machine learning to this environment? Along with the cameras that can withstand the harsh environment, but still give you all the information. With all the like you talked about a little bit earlier, the cloud changing, the lighting changes,
all the things,
all the things.
So much variance.
So much variance. So you put you're not in this nice, very controlled environment. You're in this very real world, natural environment. How the camera's just one thing. There's all these other things, right? There's all the other sensors. And then the machinery, and what you're trying to actually do with that machine. Can those, the human hand, right, is a, very complex, very dynamic piece of machine that we still have a very hard time roboticizing.
Yeah.
Boston Dynamics is pretty cool, right? They got some pretty nice dynamics, but I don't think they have a nice hand.
Yeah,
I don't think they have
focusing more on locomotion.
But,
universal robots or right-hand robotics or some of these other gripping. I don't know. But
there's those gripping technologies, right? And it's really simple. It's for the application, right? It's for the application, right? It's like, okay, if I want to grab a thing, I just need a thing that does this, and so that mimics some parts of the hand.
Yep.
But the hand can do so many different things. And so, how do we do, so that's the mechanical, more complex mechanical
how do we grow
side
more
of things.
Sophisticated in the mechanical part? Because, you're right. Right now we have it's like most very fine manipulation with in an environment where you're like, in a highly unstructured environment doesn't seem to be a thing yet. So like having
there's lots of dynamics, right? And when you get out into the real world, talk about agriculture, there's harvesting companies now. I think they got robotic, they got these vacuum suction things where they'll suck the thing with a vacuum, right? And so that can kind of work, and if you can manipulate it, and you can suck it.
Little things for picking strawberries. These kinds of things. I think I saw this at the Queensland University of Technology in Australia.
You get in there and you can kind of grab it
Yep.
and that works in those environments, but there's so many
It's
diverse
hard and not very
environments.
general. Yeah, at this point, I believe. I mean, I don't really know much,
I
but
think so, right? Like I think initially there's going to be people who are, I got a strawberry grabber,
yeah.
I got an apple grabber, and
Yep.
then somebody's going to make the universal I grab stuff.
Yep. I grab
whatever it
any
is you
fruit.
want,
Yep.
whatever it is you want me to go grab, I go grab it. Right. So the
Mm.
mechanics have to get to that point where I can just grab anything,
Yep.
and the human hand can do that. So I would
So
imagine, just because how our brain thinks, is we make stuff that is, you know. But then again, with AI, they might say, "Oh no, your hand is not the most optimal grabbing device.
yeah,
That's this other device that you
it's
can
good for
grab that's
us.
completely different
Might
than
not be
your
good for
hand."
everything else. Yeah.
So that's the other cool thing that AI brings, is the ability to rethink about our own, designs. We come up
Yeah.
with these designs, and it's like, oh, that's not the most optimal way to build a structure. If you build a structure with these very, like, to us, they're not symmetric. We typically build symmetrically, and the forces are very nicely applied across these symmetrical,
Yeah.
trusses and things. And AI can say, oh no, if you put this really long one here and this one here, it
Totally
has all the
unintuitive.
same constraints as your symmetrical thing that you've been developing for hundreds of years.
Are you familiar with much work? I'm not, but are you familiar with much work where it's like design related things that use some sort of maybe an evolutionary strategy or something in AI? Is this what you're
Yeah,
speaking about,
yeah,
or
yeah, yeah. We
I've
definitely
seen this in some
so we
academic
do some
papers?
we do some developing at Blue River, right? It's not
Oh,
it's not
yep,
cut, it's not across the board type of thing, but we do some of our own of that, right? Like we do some of our
cool.
own. How can AI affect the design?
That's
So we do
cool.
some of
Does
that,
it is
but
it just
it's
varying
it's across the
parameters in
board.
something, or like you
No,
have an existing
I
design
think
and
it
it just
is
changes
really,
the
yeah.
length of a part of it, or
No, I think it is just like you fundamentally give it a problem, and let it do its thing,
that's
right? Like
super cool.
it's actually like rocket science to me. We got some of
Yeah.
our guys, some of our, like, smartest guys at Blue River, and we got some super smart guys here.
Oh, I bet.
And some of those guys just go out and say, "Hey, I want to do this thing here. I give it a problem. I'm gonna let AI and the algorithms and the techniques
Come up with the
find."
solution.
Yeah, there you go. There you go.
Huh. I wonder. I wonder if there's difficulties there because of, I assume, well, I'm pretty sure you would have to do it in simulation, and in simulation, physics doesn't really match up perfectly with
Sure, we
our
all know that.
physics in reality. Yeah. So, like,
Yeah, yeah.
contact is very hard to simulate.
So you gotta
So,
you gotta get the test stuff up, right? You gotta build something. You gotta prototype it, get a test rig up,
yep.
see what you can learn.
Yeah, and
Blue
iterate
River,
from
Blue
there.
River, and I think most companies are all about that, right? Like, and every engineer loves doing that, right? Oh, hey, there's this new thing. We got to develop this new test rig that
I
studies
know.
this thing,
Yeah.
and let's figure out how it'll work. And yeah, totally. We
Yeah, it's fun to build stuff.
that's part of the cool part of Blue River, is that you know depending on what project you're working on, there's still that goes on, right? There's still that, hey, I got an idea. I don't know where this is going to go yet, but can I
Let
get
me try it.
a little bit of budget to build a little something, and let's see what we get.
Cool.
And if
I
and
like
if you
that.
get and if you get down the if we start to see promise, that'll continue to get fed, right? That'll continue to get, like, okay, we'll keep developing on that, keep looking
Hmm.
at that, keep figuring that out, keep coming up with that. And I think all companies at some point, I think they do. You have to do that, right? If you wanna, how did John Deere, you know, stick around this long? They
Yeah,
constantly have to
reinventing
have
themselves frequently.
somebody out there.
Yep.
Hey, I wanna,
Yeah.
I wanna figure out how to do something that's totally no one else is thinking about right
Yep.
now, and
Totally.
put a little bit of investment in that. And my God, what can come out? We've come up with some cool stuff. It's just scratching the surface.
Hmm.
But I think we got some of the right people, kind of like leading the direction there to continue us to grow there. And I
Yeah.
think, yeah, I think that, and you talked a little bit earlier about, you know, the kids and the growing of the population so that they're capable of bringing those ideas to you.
Yeah, actually, that's kind of a good segue into what I would like to ask you about, which is, I mean, so you have um, kids, and you've been encouraging them to program. Would you tell me a bit about this?
Yes. So I got two daughters. My oldest now she's a nurse, and so she was a little bit behind the power curve when I got into the
Ah,
engineering. But I did explain to her that robotics, computing, and these actual devices that she uses as a nurse are going to converge, right? And
mm-hmm.
that the device will do a lot of things for you that you're doing right now manually
Mm,
as a nurse, and so that she should pay attention to it, right? And she has, right, like she's been keeping up with a little bit of the technology magazines,
mm-hmm.
around the medical field and the
Cool.
new devices that are coming, and even like I talked to her about a month ago. She was talking to her doctor about these new what do you call them? So you've been to the doctor. They put that little thing on your
Yeah,
finger to
the
kind of
sensor
give you
that,
your pulse and system. Yeah, to
yep,
give you your
blood
pulse and stuff like
oxygen
that.
levels and
Yeah,
whatever
yeah. So
else.
she's talking to them about new ways that you don't even have to put that thing on there. You can just come in the room, and the room has the environment. When the
Oh,
patient
cool.
comes in, it just gives you like kind of the patient's whole thing, right? You can bring them in and like 3D walk around them, like they just kind of stand there, and
Cool.
you can kind of walk around and like, okay, this is going on here. Your heart rate's here. It looks
That's
like you
super
got
cool.
some destruction here on your bones, and
Mm,
technology is far away, but it's getting there, right? And this is where the future's going. And so her doctor's like, paying attention to it, and likes her because she's like interested in those things. My youngest daughter is more of the one that I have more of impact on. She's becoming a biomedical engineer right now. She's going to school at the University of Florida. And
ah,
when she was about I would say about 12, I had her writing small scripts in Python. I used to do some robotics work out of the University of Florida for a drone team.
mm-hmm.
She used to come visit me, and we'd sit there. And one of the cool things about it was there was Code Academy for Python. My daughter's super smart, and the way Code Academy is set up, it gives you a nice little introduction into programming and
Mm-hmm.
Python syntax, and so you can start to slowly learn how to program, and you can start to slowly understand Python syntax, which isn't so complicated. It's not like C++. It's a little bit more syntaxy heavy. Python, you just like you make these sentences, you make these things that just kind of make sense, right? If
Mm-hmm.
this happens, do this. If that happens, do that. And it's not a whole lot of syntax around it, just kind of indenting, which they
Yep,
learn that in school anyway. And she was able to to start developing small little programs that could do her homework and stuff for her.
that's cool.
And yeah, and so now she's like, yeah, Dad, I want to build robotic arms, and I want to build like these kind of like robotic prosthetics for people,
Yeah.
right? Because she remembers when I was in the military. I got a buddy of mine who lost his arm in the
Mm,
military, and he's got a very it works, but it's really primitive, like a
yep,
fork finger arm thing.
yep.
And she wants to give him hands, right? She wants to like hey, I want to be able to take the fork away and give him like the ability to grab things.
Yeah.
But what did she get that desire from? The wanting to do that, and it was because of the accessibility of programming
Hmm.
and things like Python and ROS, right? Python being able to give you a really high level language that isn't overly complicated to start writing a program.
Mm-hmm.
It's very close to how you just kind of think and write things down when you're writing
Yeah.
stories and things. And
Yep.
then
Fairly intuitive. Yep.
ROS gives you the ability to say, okay, hey, I got this module that does this. I got the camera. The camera takes in images, and I can get a process image. I got this sensor that tells me what the height is up and down, and I can break that
Mm-hmm.
down into numbers. Essentially, you break all of those things down into numbers, and if you understand enough mathematics, you can now take camera images, you can take sensors, you can take lasers, you can take all these crazy things, that are, no one knows how the camera works. Like, how does it take that image
the whole way
and electronically? Yeah, exactly. That's, oh my God, how long will it take you to understand?
Yeah, it's like an undergraduate degree or something.
The science behind that. But if you can tell me, hey, I can give you I can give you an array, or a vector of pixels and what those pixel values are, and those correlate to colors. Yep. And then you can just like reproject that onto another screen that just like displays numbers. You can almost see the face that you're taking a picture of, even in ASCII, right? Like even without actually giving you the color values, I can give you an ASCII representation.
Yep, or just use OpenCV and then have it do face detection or some sort of thing, some other existing library.
You learn OpenCV and you become you become a guru, right? Like if you really get into OpenCV,
or SciPy or any of these things.
Yeah, you learn the math behind it, right? So you got to learn that math behind it. But you learn the tools. The tools give you the accessibility is the cool part. You make it accessible. You make it easy for these kids to get into it. And to you get the little touches. I think I told you about this offline. Was I had a kid this January. He was Crystal Ray has a high school program where they bring underrepresented high school kids and merge them with a mentor from a tech company. And I taught this kid how to cut his camera on from a microphone using Python, using Code Academy, quickly learning how to do simple programs and modular programming. And bring in a library. This is the library for your camera. Yep. This is how you cut your camera on. There's all these other APIs in that library that can like focus the camera in, go look at different things.
That's super cool.
But I'm just gonna show you how to cut it on and off.
Yeah.
And hit record for you. And then I'm gonna show you this other library that takes your voice in and you can teach it words. Cut, teach it that. Camera, teach it that on. And it loads it from your voice. If I tell it, it ain't gonna work. But from your voice, it knows what cut means, it knows what camera on, and knows what that means. And then it sends the signal to the camera to turn on to the camera API. And he's got that working, and the kid's just like, oh, just like he was so like on 10 about it, right? And it's like I love to see that. I love to see that because that kid's gonna grow. I don't know what he's gonna do in his life. I only mentored him for about 4 or 5 months, but I showed him
wonderful though
what he's capable of doing. And it was over 4 or 5 months. I just scratched the surface, and I always iterated to him. This is just scratching the surface. If you actually want to be able to do this for real and get paid like I get paid to do it, you need to go to school. You need to learn. You need to actually understand the math behind it. You need to understand the details behind this so that you do it the most efficient way. The way we did it was a way. It worked, right? But this isn't the most efficient, the most effective, the best way to do it.
Ready, for sure.
And if you really want to get a job doing that, you can't go get a job making this right now because you're just a kid, right? But if you get a credential that says, I know how to write software, or I know how to develop cameras, and I know how to develop, sound devices, and now you can go get paid to do this. Yeah. And like, how cool is that, right? Like, how cool is it to go get paid to make these kind of devices and to make these things that affect the world? And he was he's totally stoked about it. And that to me is the key. That's the key to getting our kids back focused into, technology and to doing the smart things. I'm kind of biased. I'm a little old. I'm 43, and I think there's a good chunk of our kids, and I think every generation has this. They just want to be like TikTok influencers, and they want to do things that are like, yeah, that's cool and that's fun, but that isn't like progressing society. Right? Yeah, in some way, but you really need to be studying. You really need to be understanding, like standing on the shoulders of the guys that came before us, with this technology and growing it. And it's not easy. How learning that calculus and learning that the physics, all
the required skills.
That stuff is not easy. So how do you motivate those kids to stick with it when you got 3-dimensional calculus, you got integrals, and you're just sitting there and you're like, why am I doing this?
What is this? Yeah.
I could go be over here doing some TikTok dances. I could make my money that way. It's like, nah, you get to actually, once you learn that stuff, And what does that stuff apply to? That's another thing I think schools fail at is
I agree completely.
Explaining to you why is math important. Yeah, 1 plus 1 is 2. Okay, yeah, that's great. That's good for simple math. Why is it that I need to know the integral of something? What usefulness is that?
Yeah, this
And giving them something that is actually tangible.
totally. This is why I think it's such an important thing that you're mentoring people. It's like it's hard to expect teachers to understand the like K through 12 teachers to understand the reasons that engineers use, say, sinusoids or linear algebra or whatever math related
Pythagoras
thing.
theorem. Yeah, for sure.
Yeah, or all the programming concepts. But so, like you, as someone who actually does, it's very important for you to go hang out with kids, I think, and me too. Like this is something I hope to be able to do in the nearish future, like go help high school students or something like this. As someone who is actually applying these technologies, I could be like, oh, this is why sinusoids are relevant, or whatever, which is something my teachers were not able to give me when I was learning them.
You learn them, you get the grade.
Mm-hmm.
You know, yeah, I don't know how you got into engineering, but it wasn't because you were learning sinusoids, right? Like it wasn't, your high school math teacher.
Not robotics for sure. I got into electrical because my dad told me I should. And then robotics was like, oh, this is awesome. And so that's how I got into robotics.
Robotics that's the cool thing about it is like it's really real world. It's kind of hard sometimes for computer science, to kind of explain. Okay, yeah, you make this website, but in order to make this website, you got to know all these like data structures and all this other stuff that is not necessarily website based. And then the back end stuff is a little bit more complicated, but being able to tie it to something that's real world, and I think robotics is a very cool thing because there's just so much, especially right now, there's so much room for things that are not there. When we're kids, usually the engineers are the kids who are like, I wish this could work like this. We got this thing already, but why couldn't it work like this? Like I'm not the guy who made it, but why did they make it like that? I would have made it this way. I would have did something like this. I don't know how to do it, but if I could, I would have made it this way. I would have made my camera fly around on a drone and follow me around the house, right? Like, yeah. and then I don't have to just sit in my chair and have this video. I could just go for a walk and we could have this video, right?
That'd be super cool.
And we got that. We got that technology now, right? But if no one ever developed that and thought of that up, that wouldn't have happened. And we got to give those kids the I think early on is the fertile ground because the technology is accessible now. It's not as complicated. It's not like our grandfathers and our fathers, entry level to get in. It is now at a level where I can teach my 7-year-old daughter, hey, this is how you program a little math equation in Python. This is how you take variables in. This is how you make these variables do this math, and this is how you get a result out.
Or even this is how you talk to your camera, this is how you run an optimization, this is how you do these things, because these libraries exist. So it's a lot of infrastructure that you would have had to build yourself.
Oh my God.
And so now
optimization.
Yeah.
I just learned about that like grad school, right? Like, you optimize this thing. And what is that for? Well, you want to optimize, all of your resources to the best way so you're not wasting.
Yep.
And you don't, it's a very complex mathematical thing.
Yeah, it's a lot of calculus.
But it's a very intuitive concept. It's a very intuitive concept that you can totally teach a kid to use a library. This will optimize your output, and that's what you want to use.
That is you can show totally them on a whiteboard right. What's going on too.
Totally right. That's totally right. And then they're like, "Oh, I actually want to know what optimization is." There's a class for that. You can actually go learn the math, right? You can actually go learn to improve optimization algorithms because there's not just one. There's multiple different ones for different situations.
Tons. Yep. Yeah. Concave. It's like not the ones that are not concave. All these things.
Things. And you're constantly going to need to use that. Going forward, especially with robotics, especially with all of these different new technologies that we're developing with AI, all of that stuff. If you really want to get in, you want to make your own robot that thinks for itself. Hey, these are the ways to go. And every kid isn't going to want to do that, but I think it's going to bring a lot of kids. I think it will bring a lot of kids.
So let's see. Wrapping up because we are running out of time. I would love to hear advice that you would have for someone, say like a teenager or someone just about to go to college, who might be interested in robotics. Any advice for them?
Um, yeah, high school or a brand new college grad
Sure.
is you're definitely doing the right thing. This is the way to go. Um, I would say that one of the most important things about college is determining what you're going to do for your future. Like, what are you going to do? A good majority of the rest of your life. And robotics is the future. It is the way that society is going. For better or for worse, for the next 50 to 100 years. You can go get a job. Developing, something that is, I don't know, you can go be a firefighter or or a gas station mechanic. You can go do something that is, not necessarily, cutting edge or there's some work to be done in it. I don't want to down other degrees, but there's just some people that that have graduated college with degrees and are working at like CVS or some place that is like, you went to college for 4 years or more, and you're not even working in the area that you want to go study in. If you go study robotics, you're going to have a job for the rest of your life. Kids nowadays, if they go into school to learn software, mechanics, robotics integration, there's no end. There's no, the things that you can go get.
There's lots of opportunity.
Yes.
No end of opportunities.
There's no end of opportunities, right? And the areas to go specialize in are just, even more broader. What is it about robotics that you are interested in? I would like for us to develop a robotics degree, and I think some universities do have that.
Mm-hmm.
It's probably not very well defined, and they probably are.
I think some universities have well defined ones. But
because it's a lot of things, right? It's programming.
Yep.
It's a little bit of electrical. It's a little bit of mechanical, right? So it's a little bit of the three main disciplines, right, that we think about: electrical, software, mechanical, right? It's those three things combined, to do something real world. And so there's the integration part. And so if there's I would say a good defined robotics program would have those three things as classes. Write a little code, understand the basics of circuits, understand how mechanical devices work, and then understand how to pull these things together to do real work in the world, and then allow the student to go and, and sensors, right? Bring it in sensors, utilizing sensors, and then allow a student to go, where are you most interested at? What do you like the most? What you want sensors more? You want to write code? You want to build robots? You want to build the circuitry that powers up the motors, that powers up the the devices, and or write solar devices that bring the energy in that way.
All sorts of things. Yeah,
you
could try it out.
Oh my God, the areas of where to go and to dive in deep. They're endless, and so it's the way to go. I would even say, go get the traditional degree, undergrad, right? Go get the traditional. If you already know, if I know I want to write program, or I know I want to write circuits, or I know I want to, I'm mechanically inclined and I want to do mechanics, do that. But absolutely get your master's in robotics. Take that knowledge and then go into robotics after that.
Okay.
Because that knowledge is then going to allow you to build a better robot, right? I could probably, as an undergrad's usually too broad. You don't never get enough, and if you go too broad across all those disciplines, you won't never know enough. But if you're mechanical, you got a bachelor's in mechanical, and then I show you robotics, you now know how to apply your mechanics to this robot situation, or you know how to apply your software.
Or the control theory things you learn as a mechanical.
There you go.
Yeah.
There you go. So you get the foundation and then apply that foundation to robots. And think about what robot and what about robots. So we should be introducing our kids in high school to robots. It should be as fundamental as like, they have those old schools that were like where you had like ROTC and you had home ec and you had shop class, where they show the kids how to do some oil stuff. We should have a shop robots class. All kids go in. All kids get in it. You got to pass it, right? Like you gotta pay attention here because this is going to be part of your life, whether you like it or not. But those kids who are really into it, hey, what part of it do you really like? Because this is where mechanical engineers, they build it. This is where the electricals guys, they do the circuits. This is the control guys, they develop, how it knows when to go up or when to go down or when to go this way or when to go that way. This is computer vision guys who really get into, OpenCV, and they write codes. You got to know how to write software in order to be able to utilize the camera and to utilize the sensors. So you got to be a software engineer. So none of those kids know what they want to do. They get out of high school, they know what they want to go do. Yeah, and if you don't want to be a robots guy, then go be a banker or finance guy. I don't know. We need those guys too. We need those guys too. But the kids that are like us, I believe we're all nerds. We're all those kids who are like breaking apart something that your mom had when she was a kid. When you were a kid, you're fucking with your mom's like radio or something like that, and you're like, yeah, that's us, right? That's our type of kids. And I wish I had a high school teacher, man,
that showed
to
you
show me robotics when I was that age. Because in that age, I was even more fired up about school and stuff then than I am now, and I'm still fired up about it. But man, had I known then, I would have already picked my stuff. Like I went to the military. I did a very long around the way,
a circuitous route, to come to where you are now, working on kind of the future. Yeah,
I would have loved to have just
gone right there,
being right on it, because this is it, man. This is my passion. Creating things in the world and understanding how technology works, and then being able to leverage the technology to create a new thing. That's me. I think that's just every engineer. I think most of us, you have to be like passionate in order to get through calculus. Like you can't get through that stuff if you're not passionate about it.
Gotcha. All right. So now finally wrapping up, is there any like websites, blogs, like your company blog or any contact info you'd like to share with our listeners?
So there's two things. I don't have the websites on the top of my head, but there's two things.
I can include them in the post. So it'll be the Blue River one.
So along the lines of young kids getting into technology, Crystal Ray program. It's a high school program that I would advertise it to parents who have young children who haven't went to high school yet, who want to give their kids a little bit of an edge when they go to high school, other than just going to the top high school in the area, which that's there too. But if your kid doesn't have the opportunity to get there to the top high school in the area, Crystal Ray is particularly structured towards kids who are not going to get into the top high schools in Cupertino. The opportunity to work with professionals in the robotics field or any professional field.
Is it a common model that other high schools follow? I imagine listeners will be all over, not just in the Bay Area, too.
I'm not sure. I'm not even sure. I heard
know,
about them.
First Robotics is really good to get high school students, or maybe even younger students.
And that was my second one. That was actually my second one. So we got like 5 or 6 FIRST Robotic engineers. I got one of the guys who's in FIRST Robotics on our team, who is he's like one of the. He not only went through from grade school to high school and graduated and went on. He's like an administrator now in FIRST Robotics. And
that's
so
awesome.
he's a very like pivotal FIRST Robotics person in just the whole organization. And we probably got through him another 5 people that are from FIRST Robotics. And these guys,
that's so cool.
These guys are amazing. They're amazing. Audrow, I can't even put it into words, man. These guys, they're young and they're on it. And so I would say FIRST Robotics is absolutely a uh,
Great thing.
a good thing to get your kids involved in if you have it, right? Like that, to me, those are the things that I wish I had in high school. I wish I
Yeah,
had a
me
high
too.
school focused towards professional development, and I wish I had a high school that had the FIRST Robotics program. I would have totally partaked of it, and I would have
Mm.
kicked ass in it because it's you get because they get the kids who are interested in that. They
Yep.
get the kids who like, I want to do this. I want to make robots. I think one or two of our guys, is in the Battle Bots competition this year. They just filmed, and so they're in
Nice.
the Battle Bots competition. A couple of our guys they're not even full time employees yet. They're interning, working for NASA, helping NASA develop some of their software stuff and robotic stuff, and just a great group of having that great foundation, of the right things, and it's very targeted to robotics, which is a tough
Hmm.
thing to go find. Like, I'm a hiring
Without
manager. I have
doing
to go.
robotics.
Exactly.
Yeah.
You can find a software engineer. I can find a mechanical engineer. I can find the individuals. I need someone who understands how we do this in the robotics
Pull the
environment.
parts and how they relate.
Yes. And
I see.
that is a little bit more challenging when you get these guys like this that have been particularly focused in the robotics environment. That is so much better.
Hmm.
It is so great because they already get it. It's a real time system. It has to work in all kinds of environments. There's lots of variables. Oh my God, that is the greatest. And
Yeah.
so FIRST Robotics is my second one. So those are the
Hell yeah.
two things that I think that I would point people to go get more involved in. Crystal Ray, FIRST Robotics. There's another one, but I can't think of the name of it, so I won't bring it up. But
All
yeah,
right.
if I could start all over again, or if I could, my kids are both out of high school now. But if they if I could redo it,
They'd be doing that. I
they'd be
see.
doing that, man. They'd be doing that.
Yeah.
Let's not waste our kids' times. The future is going to be ridiculously competitive,
Hmm.
and so the better the head start that we can give them, the better. And so Crystal Ray gets you in the professional mind, high school. At the high school level, we should start thinking about, even some people would say even before.
Hmm.
I feel
But at
like
least
grade
at high
school.
school. I
I
see.
feel like grade school, you should give them some childhood, right? It
Yeah.
shouldn't be too serious, but high school is time to get serious,
Hell yeah.
and
Okay.
and from there, let's go, man. Let's teach these kids, let's keep us competitive, and let's do robotics because yeah, that is the future, man. The other things, outside of robotics areas, they're gonna still be there, but they're going to be using robotics too, man.
It's
The
true.
bankers and the what else is there? The retailers, they're going to be using robotics.
Yeah. All right. Thank you.
All right, man. So I hope you enjoy the conversation, and
My
I appreciate talking with you, man. It was great to
pleasure.
talk about Blue River Robotics and what we do here, man. The future's bright, so let's continue to contribute to that. That's for sure.
Thanks for listening to this conversation with Tobias Holmes. Thank you again to our founding sponsor, Open Robotics, and I hope to see you next time.